Hello everyone, I'm Tanushri. In this video, we are going to discuss about ER diagrams, constants, and cardinality ratio. Let's begin the video. The first topic is Introduction to ER diagrams. The full form of ER is entity relationship. Entity relationship diagrams are the visual representation of data that models the relation between entities in a database. They provides a clear and organized way to understand the structure and dependencies of a complex data system. Entities and attributes. Defining entities. Entities are the fundamental building blocks of an ER diagram representing the key objects or things within a system. Each entity has a unique name and a set of characters known as attributes that defines its property. Next is identifying attributes. Attributes are the individual piece of information that describes an entity. They can be simple, such as a name or ID, or more complex, like a detailed product description or customer address. Carefully identifying the relevant attributes is crucial for modeling the system accurately. Next is primary keys. Primary key is a special attribute or combination of attributes that uniquely identifies each instance of an entity. Primary key ensures that each record in a database is distinct and can be easily retrieved or redefined or easily redefined. Relationships and cardinality. First is defining relationships. Relationships describe the association between entities in an ER diagram. They define how entities interact with and relate to one another with the modeled system. Next is cardinality constants. Cardinality refers to the number of instances of one entity that can be associated with each instance of a related entity. This constant specifies the minimum and maximum number of relationships an entity can participate in. Next is common cardinality ratios. The most common cardinality ratios are 1 to 1, 1 to many to 1, and many to many. Defining the appropriate cardinality is crucial for accurately representing the relationships in ER models. Next is weak entities. Weak entities are a crucial concept in ER modeling. These these are the entities that cannot be uniquely identified by their own attributes and instead rely on a relationship with another entity known as the identifying or parent entity. Weak entities are denoted with a double rectangular box in an ER diagram. They have a partial key, which means they require the primary key of the parent entity to form an unique identifier. This type of relationships is called identifying, and the cardinality is typically expressed as one to many from the parent to the weak entity. Example of weak entity includes order details that depends on the order entity or employee dependence that requires the employee entity to be unique identified. Understanding the weak entity is essential for designing robust and accurate database schemas. Identifying relationships. Identifying relationships is a crucial step in designing an effective ER diagrams. Relationships represents the association or connection between entities in a database. Relationships can be one to one, one to many, or many to many. Or understanding the type of relationship is essential for modeling the data accurately. To identify relationships, you need to analyze the business requirements and the interaction between the entities. Consider the action that can be performed between entities, such as creating, updating, deleting, or accessing data. These actions will help you to define the relationships and determine the appropriate cardinality for each relation. Participation constant. It has three steps: mandatory participation, optional participation, defining constant. Mandatory participation. Constant dedicate that an entity must participate in a relationship. This means the relationship cannot exist without the presence of that entity. For example, in an order customer relationship, the customer must always be present for the order to exist. Next is optional participation. Optional participation constraints allows an entity to participate in a relationship but do not require it. The relationship can exist without the involvement of that entity. For instance, in a student course relationship, a student may choose to enroll in a course or not. Next is defining constants. Participation constants are defined when the design uh, conceptual data model. They help to ensure the integrity of the database by enforcing the necessary business rule and relationships between entities. It's important to carefully consider participation constant to create a robust and accurate data model. Cardinality ratios. Cardinality ratios are an essential component of ER diagrams as they define the relationship between two entities. These ratios determine the number of instances of one entity that can be associated with a single instance of another entity. The three primary cardinality ratios are 1 to 1, 1 to many, and many to many. The 1 to 1 ratio indicates that a single instance of an entity is associated with exactly one instance of another entity, while the 1 to many ratio suggests that a single instance of an entity can be associated with multiple instances of another entity. The many to many ratio signifies that multiple instances of an entity can be associated with multiple instances of another entity. Understanding cardinality ratios is crucial in designing robust and efficient database schemas. By properly defining the relationships between entities, developers can ensure data integrity, reduce data redundancy, and improve the overall performance of the system. Cardinality ratios also play a vital role in the normalization process, where they help identifying and eliminate data anomalies. Degree of relationship. First is binary relationships. Binary relationships are the most common type of relationships in an ER diagram. They are involved two entities and a single connection between them. For example, an employee works for a department or a student attends an university are both binary relationships. Next is ternary relationships. Ternary relationships involves three entities and a connection between them. These are less common but can be useful for modeling more complex scenarios. For instance, a student enrolls in a course offered by a department is a ternary relationship. Next is higher degree relationships. In some cases, the complexity of the domain being modeled by a required relationship with one or with more than three entities. These are known as higher degree relationships, and while less common, they provide a more accurate representation of real world scenarios. Modeling complex relationships. There are three modeling complex relationships. First is overlapping relationships, recursive relationships, and in array relationships. Conclusion and key takeaways. In this presentation, we are explored the fundamental concept of entity relationship. Diagram includes entities, attributes, relationships, and their various constants and cardinality ratio. By understanding these principles, you can effectively model complex database systems and ensure your data is structured in a logical and more effective manner. So thank you for watching my video.